So yeah, another question on board. So from my previous lesson, we learned about the D operator method and how we can use it in solving a differential equation, first order differential equation with constant coefficients. So this is another question. So we want to know how to use the D operator to solve this differential equation. So my y prime minus y is equal to e exponent x. So this is the question. Okay. So this is the question. So solution. We apply the D operator method on the left hand side, and as usual from the previous lesson, we proved how to derive this general equation. Where is it? This general equation. So here, my applying my D operator on the left hand side, we are going to get my D minus the coefficient of y, which is 1. Then bracket close, multiplying y. The D here stands for my y prime. So that's the first derivative, that's the first order, minus the coefficient of the the y, which is 1. Yeah, then we operate it on a function, a dependent variable, which is y, which is equal to e exponent x. So I try to make my y the subject. So I'm going to get 1 over d minus 1 operating on e exponent x. So I just compare this general form. So by comparing, my y is equal to 1 over d minus e r of x. So by comparing, I can see that my r of x is equal to e of x. So my 1 over d minus e operating on r of x, that's the general form, is always giving me or giving us e exponent. Then you maintain the value here, the positive part of the a, which is e exponent x, then integral of, then you write the negative part of the a, which is the negative, so negative e of x, and we operate it on r of x, or multiplying the r of x dx. So that's the general way, or that's the idea behind the D operator method. So my 1 over the D minus, now my A, by comparing, my A is 1. So my D minus 1 e exponent x is equal to, so here I'll first maintain my positive value, and it's 1. So 1x. So my a is 1. That's the positive value. Then integral of the negative value. So the negative value get the negative sign of the 1. So it becomes negative 1x. So negative ex. So negative 1x, which is negative x. Then multiply e exponent x. That's the r of x. The r of x is e exponent x. So operating on e exponent x dx. And then my e exponent minus x, multiply e exponent x, you are going to get e exponent minus x plus x. You are going to get e exponent 0, because this is of the same base, logarithmic functions. When you multiply and they are of the same base, you choose one, then you add the numerators. Minus x plus x is going to be 0. So I'm going to get e exponent 0 dx. So e exponent 0 is 1. So more or less, we are finding the integral of the d of x. So anytime you integrate the dx, you are going to get x plus c. But remember, the e exponent 2x is multiplying the integral of dx. So I know that my integral of my dx is going to be e exponent x. Then the integral of dx is going to be x plus c. That's the constant. Then we are going to get e exponent x multiplying through this, which is x e exponent x plus c e exponent x. So my general equation becomes my y is equal to x e exponent 2x plus CE exponent x. So this is my general equation. The constant is 1 because it's a first order linear differential equation with constant coefficient. It's a first order. So because it's a first order, the constant is 1. But if it's a second order, it means you are going to get two constants, say C1 or and or C2. But here it's only first order differential equation, so you are going to get only the only C. That's one constant. Okay, thank you.